Today we are going to see about construction and operation of switched reluctance motor. This is the diagram for the cross-sectional view of SRM motor. Normally the motor consists of stator and the rotor. The construction stationary part in the machine is called stator, rotating part in the machine is called rotor. The constructional details of switched reluctance motor with 6 stator poles and 4 rotor poles. The stator is made up of silicon steel stamping with inverse projector poles, and the number of poles stator can be either even number or odd number. Most of the motor available in even numbers. So next one is rotor. The rotor is also made up of silicon steel stampings with outer projector poles. The number of poles in the rotor is different from the number of poles in stator. The rotor carries the position sensor. The turning on or off operation of various devices of power semiconductor circuits are influenced by signals obtained from the rotor position sensor. This is a block diagram of SRM. SRM is nothing but switched reluctance motors. Here the SRM consists the block diagram consisting of power semiconductor switching circuits, controller, SRM, and rotor position sensor. The DC supply is given to the power semiconductor device switching circuit, which is connected to the various phase winding of SRM. The rotor position sensor, which is mounted on the shaft of SRM, provides the signals to the controller about the position of the rotor with reference to the reference axis. The control collects the information, all the reference speed signals suitable on the signal fed to the controller. Then let us see the principal operation of SRM. Here, the stator poles and rotor poles are 6 by SRM. To start the stator pole, A dash and rotor poles small a dash aligned with it. Here the minimum reluctance position and also dLA by deta equal to 0 at position integral B winding neither maximum or minimum. Now the phase in B is energized and the rotor develops a torque because of variable reluctance or resistance of various in inductance. The torque developed is equal to the 1 by 2 IB square. The direct such that B dash and small we try to align. If this torque is more than the opposite loading torque and frictional torque, the rotor starts to rotate. When the shaft occupies the position such that B dash and B dash are aligned, that means theta equal to 30 degree. Now the phase unit B is switched off and phase unit C is turned on disappear. The rotor experiences the torque dLC by deta equals 6. So rotor continues to rotate. When the rotor rotates in further 30 degree, the torque developed due to the winding C is 0. Then the phase winding C is switched off and phase winding A is energized. When the load torque is increased, the speed of motor end tends to fall so that the power balance maintained. If the speed is developed at the same value, the developed torque is increased by increasing the current. Thus, the motor is drawn by the mains by yours. Take place when the load torque reduced to electrical mechanical power conversion takes place. Thank you.